All right, I thought I would try to clean up some features regarding a member connecting to a space, which is sort of in a broken situation since I switched from the calls I was making to Space Channel into an event sourced way of doing things. So we have this TypeScript types file with a list of all the events I'm handling now. So right now, these things are being emitted. A member can enter a space, or they can choose to observe a space. So this is awkwardly named member observed, but there's two ways of entering a space. The difference between them is that when you enter a space, you will be providing position and rotation of your avatar, and any movements will be tracked. Whereas if you come in as an observer, you don't need to specify your position, and your position is not tracked, so you will not generate member movements. Do we generate member left for observers? That's a good thing. So in a previous video, I talked about member left, which is actually a server-side event, because if you disconnect from as a client, you can't actually emit this event because you're disconnected. You're not there. Okay, so these are the events around members, and what I wanted to clean up is some of the code around leaving and joining, and also being able to see each other. So one of the bugs right now is if we load up this space here, and I'll pull this over here, and I'll enter one of these spaces. So I'll enter A, for example. So now I'm in this space here, and because he already emitted his member entered event, somebody who comes in late to this space, I gotta sneeze on that. Oh, excuse me. Somebody who comes in later to this space. Okay, so now I'll just move over here. So this person can see this person over here, but this person cannot see this person because he joined late. So if I turn, I'll just turn around, turn. Right, he won't find anybody, and that's because this person emitted an event to nobody. Nobody was listening, but when this person joined, it emitted a member entered event to this side. So then he goes, "Oh, I know to draw you." So that means that we need a way of sharing who's in the space to any latecomer. And the way we were doing this before was in the space channel. When you first join the space, we send ourselves a message called after join. This after join message is handled down here. And we do some presence tracking. We also push presence state. And this is enough to give you a list of member IDs of all the members that are connected. However, this isn't exactly what I want, because if you enter the space using the observe button, for example, you say you want to enter the space. Maybe I should just call this a visit, because I now have two options. One option is enter, the other is observe. So this is the observe, member observe that I'm talking about. If you click on this, see when I move around, you see it's not generating any movement. I'm not actually making events as I move around, because I'm an observer. I'm not a participant. People don't need to draw me. They don't need to draw my avatar. So the presence, Phoenix presence, however, tracks connections. And so that's not exactly what I want. So even though we can get a list of member IDs for everyone who's connected to the channel, this is not giving me only the people that are in the room. So one way to change that is to add more information to the presence track. So right now, presence track is tracking the member ID and a piece of metadata, which is whether you are entered. So this could be whether you've entered or observed. And so this might actually be a fairly good way of tracking who's here. Let's see, after join. Do I get information about whether you've joined or entered? I don't think so. We're not actually sharing that information here, because these params come from, I believe, Space Broker. In Space Broker, we have a socket, and a socket has a channel, and there's no additional arguments, because at this point we're setting this thing up statically. And then when somebody has clicked on the enter, we're combining the camera ready with the enter in order to forward this information that sorry, it is, we connect to the channel after we understand their choice. Connect to channel. So here's their interaction choice, which has a value. It's like connect to channel. If I could connect join. So we're not able to send any variables here at this point, which I think is fine. Okay, so that means that the Phoenix presence can't, we're not really pushing any state data in there, which I think I prefer to do. We'll keep it simple. Where am I? After join. Okay. After join. Here it is. So we're pushing this. That's not useful. Although when you connect, you're not likely to change the status, so it actually makes it pretty good. All right, present state. Let's look at the present state. Here it is, present state, get an object. That's the member ID, and then you get this metas array, which is just this thing, Phoenix reference. So we could put some additional data in here. For example, I could put choice was to enter. So if I save this away, let's restart the server. I'm going to clear this. So when I enter here, here's my present state. This thing says choice enter. And so if the second person enters, I think you'll see both people. Let's see. Firefox. So this person gets a present state. Yeah, they get both people here, and this person over here gets presence diff. So he gets a join, and this one is choice enter. Okay. All right, let's try to pass it there. That might be enough for us to draw the people in. Okay, so how do we get this choice in here? So in order to know this, I think we have to put it in the socket. So that means it has to be available at the time you join. So it has to be in these params. So that means that Spacebroker has to be able to send it in. Since this doesn't take any parameters here, the space channel definition, where is it? Here. Let's put this back. I worked on this before, so I recently took it out, so I kind of still remember this. So space channel params can be any params you want to send to the channel. So I will initialize this in the beginning with this space channel or channel params as an empty object. So I've said it can be of any type. The socket can take params, but the channel can also take params. So space channel is this socket channel, and the second argument, chan params, can be an object. But if I define this right now, then you won't be able to, like, we don't have the value that we want to send it. So I'm hoping I can say that this object that I want to send is this channel params. And then I'm hoping that just by not replacing it, by just adding a key into it, such as, let's say this was choice, and let's say we don't know what the choice is yet, so it's that. And so maybe this can be a little bit more strongly typed. We'll say it's a choice, and this is a string. Okay, so we're sending this, which is going to be an object that looks like that. So now, when we now we need to populate this, and the way we're going to populate this is we're going to wait for this signal here, signal hub local on interaction choice, subscribe. So we're going to, before we connect a channel, we'll just modify this thing. So channel params dot choice will equal to the choice value. And to understand what this thing is, this interaction choice, we'll have to look at signal hub. So signal hub is a series of definitions. So we have signal hub has a key of local, which is an emitter of local events, and that is a type here, local events, and one of them is the interaction choice. So interaction choice can either be enter or observe. And so somewhere in the code base, something is emitting enter or observe. So we simply have to search this in our code base, interaction choice, interaction choice, and you'll see it's being emitted in one of the Svelte pages. So here's a callback where we emit into the event name, which is interaction choice, the value of enter when you click on the enter button. So we're rendering, welcome observe callback, this observe callback or enter callback. So this is the enter button and the observe callback. And inside this component, we're rendering this button, this one called the enter callback, the other one called the observe callback. And all these things are doing are defining what to do when you press that button. So one of them says emit the interaction choice with the enter value. This one says emit the interaction choice with the observed value. And this is the part that listens for it. So when we receive an interaction choice, we're going to subscribe, set that choice, and then connect to the channel. And here there's no mention of parameters because that's set up in the definition of the channel. Here we're just joining. And then we're going to, here's some callbacks. So after you've got confirmation that you joined, you're going to emit your own event saying that space channel is connected. So now in the space channel, we can probably listen for the params. So here's the params. It's the second parameter. And I think we can maybe put that into, first, let's see it. Let's just console log it out. We'll do that. And we'll restart the server. So now I expect an output here for the params of the choice. So if we go here, I'll load my space, enter into A. So when I click, let's say observe, here's the choice observe. Okay, so we see that this gets the map. And so we can send this choice in the as a tuple after join.
I'm not sure I understand.
Whoa.
Is there something else I can help with?
No. Is a tuple of params choice. So this would be either enter or observe. Then in the after join handler, I will listen for a tuple of after join followed by a choice. And then that choice will be here, passed back. In fact, I could just put the params. In case I change the params, I can put the params here, and I can put this params here. Whoops, I wanted to see this documentation here, so okay. Oh, this might need to be a symbol. Let's see what happens. So you're sending params. Params and just send the params. Alright, let's look, observe in the front end to see what presence state gives us now. So I clear this, I'm going to say observe, and here's our present state. So we see choice observe, so that seems to have worked out. Let's join again. This time I'm going to say enter, and here the presence says enter, and also diff. This also says enter. So it seems to be working out for us. And does that persist across the browser? So this user over here is called LT4. And so this person over here joins as well. So we're going to get the presence diff for myself. So joining is 503. My meta says I'm entering, and the present state we get 2. So this one says they were entering. Yep. Okay. So now I can use this. So now I have a bit of data. So if we want to draw them, let's see if we're emitting that event though. So back to Space Broker. So these are anything that I'm receiving from the channel, from the space channel into Space Broker. I'm doing this. So incoming. Okay, so the incoming would be Phoenix diff. Okay, so let's look at the signal hub for incoming. Incoming events. You can have presence diff and presence state. Okay, that is pretty good. So presence state, I think, only gets emitted once when you join the room. Any other time, it's presence diff. So we can listen for that in Scene Manager. And all our events for the event streamers up here, but we can listen for a different kind of event, which I think is called presence. So presence state. Let's see if there was anything that was listening to presence state before this. Okay, it doesn't seem like there was. I can create one here. So this is the code that's listening for incoming event. So these are event stream, but presence state is not part of our event stream. This is part of Phoenix, so this is kind of an exception. So we'll listen to Signal Hub on incoming on type of event is presence state. So anytime we join, we want to subscribe to the state message, which is strongly typed. Okay, we want to do something. Whoops. Okay, so the keys in state are simply the member IDs. So these are member ID. And then for every one of these, I want to call this find find or create avatar using the ID will be the member ID. Oh, but you know what? Here's the problem. I don't have the position and rotation, which is required to know where to draw them. So that's why present state isn't totally adequate. Yeah, so this idea didn't really pan out because I don't have this portion here. I don't know where they are. And metas, as I found out, is not a good way. This thing over here, in the after join area, this thing over here, this params, is not a good way to update it. So, because they kind of cache it. They don't expect you to be changing it all the time. So if you put the position rotation, it's the initial place that you have it. So it might allow you to draw it initially, but then if you want to I mean, that could work. It could still work. But then I feel like we have a better mechanism for this later. So let's explore the other way of doing this. Okay, so this is some old code that we can comment out. Is that the way we were doing it before is after join we would send the position rotation and then we would cache that into an ETS table. The new way is that we're getting it through a stream and we don't get it on the join. So then we publish this out as yeah, when would we publish this out? When would we say, hey, here's everyone in the room? This is doing quite a lot before. So I need the position and rotation when the way I was doing it before is back to the space broker where in this channel params I could add another one, position and rotation, but kind of don't really want to. I want to centralize all the movements using the event. So if somebody entered, we should build up a cache and then allow anyone who's entered for the first time to get the cache. Yeah, let's do it that way. So we generate an event called member entered. And we generate that. So here's the type, member entered. And we create that. Let's see, this is in a test. Now we create that on the client side. Here. This is us creating the event. And it's a combination of the camera was ready, they made an interaction choice, and the choice was enter, and the space channel is connected. So all these things are true, or all of these signals are put together, which means they have to be emitted at least once, because this is waiting for all of these signals. Then we subscribe to their values. Here's a position, rotation of the camera, the choice, and then we don't care, we just need that we waited for it, so this is an underscore. And then we're going to send, if the choice is enter, we say member entered, otherwise we say member observed. And then here we have this initial position rotation. So this gets captured as a type of event. So outgoing emit is listened to by space broker. Anything on outgoing is then sent to the channel. So we have here anything outgoing on event is sent as space channel push event, which goes to the Phoenix channel. Phoenix channel has a handle in event, and here's the payload. And this is where they go to process the event. This gets into the gen server for process event, which does a cast. So you do a handle cast on the event right here. So you have a message, a payload, and a timestamp. And here it doesn't really care what it is. It's sending it off to somebody else to save it, and then it's broadcasting it to every other member. So what I think we could do here is we could maybe cache the member position for everyone. But if you do it here in the gen server, it kind of is a bottleneck. So every client is sending a lot of camera movement, position, and rotation. If they then forward it to the space server handles messages in order, it becomes a bottleneck. But one of the things that I did was that in the creation of the space server, in its initialization, I created two ETS tables. So one's for member movements and another one for member states later. This is the important one now. But once you have this address, which I store it into the space server as this reference, member movements, any other process can write to this ETS table. And so Space Channel doesn't actually need to wait for it to go to the gen server and have them process it. We can cache it into the ETS table here. So this might be a more parallelized way of caching that table. Because you can have each space channel, which every Phoenix channel, every connection will be its own gen server, rather than going to space server, which is a single gen server. So we can cache member movement here. In order to do that, we would need the reference to the ETS table. So if we look at after join, there's no reference to the ETS table here, but that's what this bit of code was doing before. So after we join, we're going to ask for the references. given the socket assigns space ID. Socket assigns space ID. Okay, we have that. If we get an error that this process isn't available, then we can just say push the socket server lost, which will cause a redirect. Otherwise, we will have reference to the two ETS tables. That's the return result of this. And then here, whoops, we can do the rest of this. So we're not going to do anything with member states yet, but member movements is a reference to the ETS table. So let's put this into the socket. So we can say socket assign socket key value. Okay, so now it's in the socket. So after join, we simply pull down the reference to the ETS table. We set up presence tracking. We push the presence state into the channel, and we set up that the space server member connected. Okay, that's for setting up future disconnects. Okay, so we have this thing. We're connected to support So now that we have a reference, let's handle the process event bit. Handle. Okay, so some of these I think can be deprecated. We really only need this. We're not going to handle a camera moved. We're not going to handle spaces API. We're not going to handle that a state was patched or that a state was changed anymore, because everything, just about everything, is going to go through an event. And it's going to be processed in the event stream, but the exception to this is member movements, because we don't want to have a long delay in eventual consistency, and we don't want to have a bottleneck in a single gen server. So we're going to cache our own member movement directly in here, and now we can get a reference. So we have socket assigns member movements was what that's called, right? Well, where's the after? We pushed this thing, member movements. And now we're going to write to it. So how do we write to it? This is how we wrote to it before. Like this. Of course, you only want to do this if it's the right event. So let's call it, let's see, cache member movement if event is camera movement. So we can say can basically have a function head for this, right? Cache member movement with the payload. And then we create this function. And the payload is a map with an M, which is member entered or member moved. So we'll call this payload. Or member moved, so we create another function head. The M can be member moved, which is a payload. And in both cases, we're just pushing them into the ets table, essentially storing it with the key being the member ID. And when you handle Space Channel, your outgoing event is your own member ID. So we don't really have to dig through for other people's member IDs. We only need to process our own. Now the payload, if we recall, for member entered is an M, a P as a member ID, which is going to match our channel member ID. Then we've got a posrot for entered, and for moved also posrot. So both of these look the same. So these are just going to be M and then P that has posrot. This has a P. Posrot is equal to posrot. So posrot is a position and rotation. If you look over here, the definition of posrot is just an object with a pos and a rot. And they're both array vectors, arrays. So with that, member movements, we're going to need to pass the reference, which is assigns member movements. So let's hand them down that reference. So here's member movements. Okay, and then finally, we need the socket, otherwise we won't have this. I guess you could just get it from here. Member ID. Sure, we went to all that effort. Let's just do that. And finally, we need to define what these things are. So it will be pause pause rot, pause, and position X, position Y, position Z, and rotation X, rotation Y, rotation Z, rotation W is pause rot, rot. So I guess I didn't really need payload here. Okay, so then we do the same thing here. Copy, paste, get rid of payload. And then any other type cache member movement, I don't care, and I don't care. We're not gonna do anything essentially. So that means that when we're processing these movements, if you find a payload that matches member entered and member moved, entered and moved. Oh, maybe we want member left. Although we're never going to get it from the client, because the client, this is a server side generated event. Okay, but if you get this, this helps you update the table, the ets table, and then when you join, you need to push them that ets table. So here's, finally we complete this whole circle. We go to space channel where we're caching it when every time we get these events. And so now when somebody does join, we go to after join. We grab the references, and we have member movements, and we pushed present state, which was all this kind of stuff. But maybe instead of pushing that, you push the member movements. So what is member movements? How do we query it? Member movements. We do have some logic. When you terminate this channel, we'll remove ourselves out of the ets table, which is good. Here we go. Member movements to map. Takes the reference and then creates pause rot with the payload here and puts that in again. Okay, I think this is what we want. Movements to map. Are we using that anywhere? Tell us about existing map members. Okay, push to the socket members. Okay, I think it's something like this. So we haven't done the other side, but when we push this out, instead of present state, this is more like channel. So we can call this presence of channels. Well, we got to keep the name the same right now, but we can do this additional thing, which is we'll push into the socket members, and we'll comment out the states for now, and this will just be movements with member movements. Now let's try it out. So there might be a race condition. You might not be able to detect your own, because as you're joining, I don't think you have your own avatar to draw yet. There might be a race condition here. Let's see what happens. Members, movements, that's empty. Yeah, I don't have my own. Yeah, because we're waiting for it to but at the time we join the channel, we don't have our own event because we don't fire the member entered event until after you join the channel. But this after join thing is sending it as we join the channel. So one way is to take it out of here. We can push it someplace later, like after we receive another message. So to do, move this to after member entered, maybe. But what we wanted to test is if the slate joiner can receive the events. So the Firefox here would be the late joiner. So this person is about to enter. And here's members. And it works. So we don't get our own, but we got this because by the time this guy joins, it's already in the ETS table. So I think if we reorder things, it might be possible to get both. Instead of getting the message when you join the channel, get the message after you say you're joining the space, which might help with that. But at least we're getting a little bit closer to being able to draw the avatars when you're joining a space late. And we're a little bit past 8, so I'll stop recording here.